Saya akan pastikan untuk membuat projek untuk pengurusan pelajar ibu dan kelas. Macam tadi saya buat projek pengurusan masalah kenapa bayi menangis. Kan macam cikgu cakap. Jadi pada frekuensi tertentu nada ada sekian, lapar. Sekian, sakit. So jangan kata kita bidang elektrikal, kita tak ada dalam bidang perubatan. Kalau politeknik Syaram, dia ada bidang perubatan.
Boleh jadi Syaram.
Kalau elektronik perubatan, gaji lumayan lah.
Wow.
Cumanya kalau 100, kita seorang je. Kalau kita seorang je.
4,000 pound. Wow.
Okey, so itu orang kata tu lagi. Jadi topik 4 dan 5 saya dah 5 dan 6 nota tu dah tukar tadi. So kita boleh tolong sikit lah. Kalau kita kata tentang frekuensi F, apabila dia ada gangguan daripada AC supply, so biasanya kita akan selesaikan untuk menghilangkan noise tu, gangguan tu. Bila kita nak hilangkan gangguan atau noise pada satu circuit atau pelita, especially dalam bidang audio system, so biasanya kita akan gunakan filter. So dalam filter ni biasanya ada bilung lah untuk menapis. Kalau kita tengok daripada AC telegraf dia line, okay? Kepada DC dia akan jadi straight line. Tetapi daripada transformer, daripada supply main masuk kepada transformer, keluar transformer still lagi AU, authority current. Dia jadi DC apabila dia masuk ke filter, dia masuk pada penerus, pengubah pengatur itu adalah baru dia jadi DC, straight line. Tetapi sebelum dia straight line, dia ada lekuk-lekuk sikit, ada gangguan, ada tak cantik lagi noise tu. So dari filter, ada baru provision filter sama ada pi, L5 induction, kapasitor sebagainya tu, baru dia akan jadi straight line. Okay, itu lagi filter. Dan dalam kabel juga pun ada gangguan. Bukan manusia ada gangguan ni. Tak ada ekor ni.
Gangguan ni, gangguan mana cik?
Gangguan perasaan ni. Tak ada. Manusia dia tak tahu kan. So, tengok kabel. Sebab dalam kabel ni pun dia ada noise dia. Dan ini jenis yang bagus lah. Jadi kalau ini, harga dia lebih kurang, buat semuanya harga dia lebih kurang RM70. Tetapi kalau gunakan mic kabel ni, awak boleh dapat mungkin 300 meter. Ini cuma dapat 2 meter. Untuk ini dapat 300 meter. So, kualiti dia. So, sepulang pada kita lah. Nak kualiti macam mana kan? Okey, ini RCA mil. Ini adalah RCA mil.
Masuk. Satu kamera ni. Lagi depan tu.
Ini objek min sunyi.
Ini selalu ada lubang cik tunjuk.
Ya,
Objek.
sunyi.
Bismillahirrahmanirrahim. Dengan nama Allah yang Maha Pemurah, lagi Maha Mengasihani. Alhamdulillahi Rabbil Alamin. Segala puji tertentu bagi Allah, Tuhan yang memelihara dan mentadbirkan sekalian alam. Ar-Rahmanir-Rahim. Yang Maha Pemurah, lagi Maha Mengasihani. Maliki Yawmiddin. Yang menguasai pemerintahan hari pembalasan hari akhirat. Iyyaka na'budu wa iyyaka nasta'in. Engkaulah sahaja yang kami sembah, dan kepada Engkaulah sahaja kami memohon pertolongan. اهدنا الصراط المستقيم tunjukilah kami jalan yang lurus صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين yaitu jalan orang yang engkau telah kurniakan nikmat kepada mereka, bukan jalan orang yang engkau telah murkai, dan bukan pula jalan orang yang sesat.
Okey, so tajuk kita adalah transformer chapter 5. Sebenarnya kita secara tak langsung kita dah belajar, kita dah sentuh pada bab-bab yang sebelum ni, dan nota ni disediakan adalah syllabus lama, dan untuk DJJ2022 ni adalah syllabus baru, di mana untuk syllabus baru dia cuma tinggal 5 bab sahaja digabungkan, 5 bab telah digabungkan jadi satu. Jadi sebelum kita tadi tentang transformer, kita cakap transformer, kita akan tengok video dulu.
Transformers are capable of receiving AC power at one voltage and delivering it at another voltage. In this way, they help achieve better transmission efficiency while transferring the power over longer distances. In this video, we will go through the working and construction of a three-phase transformer by starting from its simplest form. The basic working principle of a transformer is simple: electromagnetic induction. According to this principle, a varying magnetic flux associated with a loop will induce an electromotive force across it. Such a fluctuating magnetic field can easily be produced by a coil and an alternating EMF system. A current-carrying conductor produces a magnetic field around it. The magnetic field produced by a coil will be as shown in the figure. With the fluctuating nature of the alternating current, the magnetic field associated with the coil will also fluctuate. This magnetic flux can be effectively linked to a secondary winding with the help of a core made up of ferromagnetic material. This fluctuating magnetic field will induce an EMF in the secondary coils due to electromagnetic induction. Since the turns are arranged in a series, the net EMF induced across the winding will be the sum of the individual EMFs induced in each turn. Since the same magnetic flux is passing through the primary and secondary coils, the EMF per turn for both the primary and secondary coils will be the same. The EMF per turn for the primary coil is related to the applied input voltage as shown. As a result, the induced EMF at the secondary coil is expressed as follows. This simply means that with fewer turns in the secondary than in primary, one can lower the voltage.
Ya, so yang ni adalah NS lebih kurang daripada NP. N apa?
For the reverse case, one can increase the voltage. But since energy is conserved, the primary and secondary currents have to obey the following relationship. Three-phase transformers use three such single-phase transformers.
So, beza three-phase and two-phase transformer. Sekarang ni adalah
but with a slightly different coil configuration. Here here, the primary and secondary coils sit concentrically. Two more such windings are employed in a three-phase transformer. Transformers with high power ratings generally employ a special kind of winding, known as a disc-type winding, where separate disc windings are connected in series through outer and inner crossovers. The low voltage windings are connected in a delta configuration, and the high voltage windings are connected in a star configuration.
So, star dan delta. Yang sebelum ni kita belajar sebelum teori kan. Ini keadaannya.
Thus, the line voltage further rises to root 3 times at high voltage side. This also means that, from a three-phase step-up transformer, we can draw 4 output wires, 3-phase power wires, and 1 neutral.
So, 1 neutral tu yang tengok tadi. Dalam pada star.
High voltage insulated bushings are required to bring out the electrical energy. The core of the transformer is made of thin insulated steel laminations.
So ini kita tengok binaan dalam. Sekarang kita tengok ombak tu tak tahu berapa benda di dalam.
Such steel laminations are stacked together as shown to form 3-phase limbs. The purpose of thin laminations is to reduce energy loss due to eddy current formation. The low voltage windings usually sit near the core. Various kinds of energy loss happens while transferring power from the primary to secondary coil. All of these energy losses are dissipated as heat.
Apa maksud yang ketiga tadi? I square R loss. Power, heat, formula bagi power.
So usually the transformer is immersed in a cooling oil to dissipate the heat. The oil dissipates the heat via natural convection.
So radiator ni apa?
Oil in the tank will expand as it absorbs the heat. A conservator tank helps to accommodate for this volume change. To know more on different types of transformer cores and windings, please check out our other videos. Thank you.
In this video we're going to be looking at transformers, and here's an example from my right coils. It consists of 2 coils, a primary and a secondary, and these are surrounded by a very substantial piece of iron. The iron actually goes through the middle of these 2 cores, and this is something what we call a G-core. It forms a B-shape with an end plate on it. The primary is much thicker wire because it carries more current.
Saya harap dia present bukan dalam tu.
And the secondary has a lot more windings on it, and we'll see why later, but basically this transformer has 240 volts in and around 2000 volts out. It's what we call a step-up transformer. So what we'll do is have a look at how does this thing work. Transformer relies on 2 key physics principles: electromagnetism and electromagnetic induction. Electromagnetism is when an electrical current generates a magnetic field. Electromagnetic induction is where a magnetic field causes an electrical current to flow. As you can see, one is just the reverse of the other. The basic transformer construction consists of a primary coil magnetically linked via an iron core to a secondary coil. The primary coil generates a magnetic field, and the secondary coil converts that magnetic field back into a flow of current or a voltage. So if we look at what goes on in a wire when we pass a current through it. When we pass a current through a wire, the ZR is representing the increase in current flow, a magnetic field is formed. to get a stronger magnetic field, we get more current to flow through the wire. Alternatively, what we can do is use 2 wires. Doubling the wires effectively doubles the current flow past a certain point, and therefore it doubles the magnetic field strength. We can use this in a transformer to make some very strong magnetic fields by using a coil. We can use this principle of multiple wires to greatly increase the strength of an electromagnet. By looping a wire into a coil, the same current carrying conductor passes the same point repeatedly. The magnetic field from each wire effectively adds together and makes for a very strong magnet. So if we look at what goes on in a transformer core, we start with our coil of wire. We now take a cross-section to the coil and only consider the wires going into and out of the screen. By convention, we represent objects going into and out of the page using dots and crosses. And imagine an arrow being fired from a bow. If you can see the cross of the feathers of an arrow, it's travelling away from you. If you can see the point of the arrow, it's heading towards you. We can now have the magnetic field of each conductor as we've seen previously. The magnetic fields actually add together, creating one larger magnetic field. And we can represent this with field lines showing the combined or the resultant magnetic field.
So many classes
What we can then do is wrap this coil around an iron core instead of a loop of iron. Now when we do this, because magnetism passes through iron much better than it does through air, we actually find that the magnetic field is constrained within the iron core. It permeates the iron core. Permeates just means travels through, basically. Iron can be several thousand times better at conducting a magnetic field than air. So if we now look at the primary side of the transformer, we can see how we generate this magnetic field which passes through the secondary coil. And what we'll now look at is induction in the secondary coil. The principle of induction involves moving a magnetic field past a conductor. In this view, as we move the magnet through the wire, some electrons move. We move the magnet the other way, and the electrons move in the opposite direction. Key thing is, if I move the magnet faster, more electrons move. So the faster I move the magnet, the greater the current flow. But key to this is it's a moving magnetic field that causes the electrons to move. In other words, a changing magnetic field generates a current. So let's have a look at that inside the transformer. First, looking at the primary side of the coil, the red arrows represent the magnitude of the current, so bigger arrows, bigger current. I increase the voltage, the current increases, and I get a growing magnetic field. But once the current is the same, the magnetic field is static, it stays the same. So let's look at that again. Increasing voltage, increasing current, changing magnetic field. Voltage stays the same, current stays the same, magnetic field stays the same. Key thing is, the voltage is only induced in the secondary coil when the magnetic field is changing. So as long as the magnetic field is changing, we've got the voltage in the secondary coil. But once the magnetic field stays the same, there's no voltage induced. So just watch that again. Changing magnetic field, we have a voltage in the secondary, but when there's no change in magnetic field, we have no voltage. So what we actually need is an input voltage that changes constantly. And we can do this using a sine wave. As you can see, the sine wave constantly changes voltage, which constantly causes a change in magnetic field, which means we're always going to have a voltage induced on the secondary. So we now have seen how voltage and a current flow can be induced in the secondary. The induced voltage depends on the strength of the magnetic field and the number of turns on the secondary coil. More turns on the secondary will generate a larger voltage. The strength of the magnetic field, though, depends upon the number of turns on the primary. So the voltage output of the transformer depends on the relationship between the number of turns on the primary and the number of turns on the secondary. So let's now have a look at that relationship. This is the transformer formula, and it's one that you need to know. It simply tells us that if we take the ratio of the voltages, secondary divided by primary, it's the same as the ratio of the terms, secondary divided by primary. The easiest way is to go through some examples. If we take 10 turns on the primary and 10 turns on the secondary, we look at the ratio secondary divided by primary, and it's 1. 10 divided by 10 is 1. If we put that into our formula, and then rearrange the formula, what we know is that the output voltage on the secondary is 1 times the voltage on the primary, or that actually both voltages are equal. So equal number of turns, equal voltages. 240 volts in would give us 240 volts out. 10 volts in would give us 10 volts out. If we look at a different example where we have 10 turns and 5 turns, we now have less turns on the secondary. If we take the ratio of that, 5 divided by 10 is 0.5. We put that into our formula, rearrange it, and this tells us that the voltage on the secondary, the output, is half of the voltage on the primary. In other words, the voltage has stepped down. It's a step-down transformer. We have half the turns on the
Step down. Apa maksudnya?
on the secondary, so we have half the voltage on the secondary. You can probably guess what happens when it's the other way around.
Kita tengok pada bilangan bilikan untuk menentukan sama ada penurun ataupun naik.
Again, work out the ratio, put it in our formula, rearrange the formula, and this now tells us that when we have twice as many turns on the secondary, we get twice the voltage on the secondary. This is called a step-up transformer. So in summary, voltage causes electrons to flow. Flow of electrons is a current. The current generates a magnetic field. By looping the wire, we can increase the strength of the magnetic field. The magnetic field passes easily through iron, and changing magnetic field induces a current in a conductor. Therefore, transformers have to use alternating current. It will not work if you just connect them to a battery. The output voltage is equal to the ratio of the number of turns multiplied by the input voltage, or in other words, the ratio of the primary and secondary voltages is the same as the ratio of the primary and secondary coils.
So dia kata apa? Rasio ataupun nisbah untuk primary dan secondary adalah depend pada Okay. So dua video yang kita dah tengok tentang transformer tadi. So kita akan masuk pada chapter ringan, chapter 5 berkaitan dengan transformer. Sekejap kita boleh tengok kita selalu. Okay. So itu introduction dia. A transformer is a transfer electric energy, tenaga elektrik dari satu state kepada electronic induction, satu transformation. Dia menggunakan existing voltage. Dia gunakan murah. In case of discrete transformer, biasanya transformer tadi kita ada dua kategori kan. Satu step up dan juga step down. Di mana dia step up, di mana step down? Penggunaan dia. Step down saja pun. Apa berlaku step up, step down? Dari segi frekuensi tak berubah. Kalau kat Malaysia ni kita 50 atau 20 kan? So step up, step down tu tengok pada penggunaan tempat lokasi dantar daripada talian pemasaran ni. Ok, ni jenis-jenis transformer sama ada single phase ataupun three phase. Kalau dalam video tadi tu dia tunjukkan kalau three phase tu ada 7 coil lah. So three phase, single phase dan sama ada core and winding ataupun helix and lead coil. So kalau di makmal mesin kat belakang tu ada satu replika. Yang bukan replika, maksudnya replika tu benda yang original tapi tak digunakan, so kita gantikan sebagai kita punya sensing. Okay. Ini binaan construction of transformer. Dalam summary tadi dah kita dah tentang apa itu flux dan sebagainya, istilah tu kita dah sentuh. Kemudian pada transformer ni, so ini adalah daripada masukan, ini adalah daripada keluaran. So N adalah bilangan inputan, coil tu, M1, M2, ni primary, ni adalah secondary. Kemudian ni kepada pumpan lah. Kepada pumpan tu maksudnya akan kepada next data. penerus penapis penerus pengatur penapis baru pada betul-betul lah. Okay. So ini daripada AC supply. So AC supply ni adalah AU. Kalau kita tengok dalam video tadi pun dia tengok AU. Ini daripada mana ni? Kita contoh. Yelah, sebab kita ada dua kaedah kan. So kalau plug sistem kita tu, dia masuk pada TV. Dah tak ada, dah selalu menurunkan dia daripada 240 kepada berapa. Kalau radio kat rumah tu kepada berapa. So dah ada video ni lah, transformer dia dalam tu. So ini adalah, kalau simbol macam ni terus apa? Transmisi. So daripada simbol kita akan tahu transformer ni binaan dia jenis apa kita boleh tahu. Kalau sini transmisi, kalau tak ada udara, felix, kalau putus ada sebagainya lah. Untuk primary dan juga secondary. Formula kita dah sentuh dulu, iaitu NP, NS, VP, VS, IPIS tu tak ada yang terbalik. Okey, ini core dia, characteristic. Jadi, so contoh apa, 50, laminate shield, single. So apa maksud 50 tu? 50 keping. 50 keping. Boleh. Berat tu. Ini model ini jenis solar core construction. Right? So yang kita akan gelurkan ni tepi. Kita kaki kanan je. Alright. Ini core type transformer, jenis core sama ada bentuk shell, segerang ataupun the core type biasa dia segerang. Ini kita gunakan di side kiri kanan. Tapi ini di bahagian tengah.
Itu dekat NB banyak.
Macam ni ada. Sebab sebenarnya saya lebih suka kalau you all buat lawatan. Saya pun tak tengok dia punya pelibut di awal. Kalau tak kita pergi lawatan ke stesen jenis kuasa listrik ataupun di pecawang-pecawang. Kat situ kita akan tengok dia lebih detail dalam semua part. Okey, tapi kita jadi pelik lah kenapa mekanikal dia pergi Alright, so transform principle operation. Ini adalah operasi dia lah berkaitan dengan transformer, binding NS, VS, rotan masukkan, bilangan. So akan ada arus dekat situ. Jadi yang penting kat sini sebenarnya kita nak create formula tu. Kita ada NP, NS, VP, VS. Ni apa ni? IS, IP. So nanti kita akan tengok lah. Boleh ke bagus ni kita ubah? Boleh. Boleh kan? Alright. So itulah sebut kait. Ini prinsip lah. Bagaimana semula ataupun menghasilkan tenaga itu atau prinsip itu. So kalau E1 equal to V1. So E tenaga dan voltage ataupun power E2 V2. So dia pada langsung. Alright. Jadi tu kita tentu tadi. Ulang balik. Kita pakai belakang ni slide sambung. Okay, so N1. Okay. Baik, kalau di sini dia sebut sebagai V1 over V2 equal to N1 over V2 equal to I2 pertama I2 over I1. Jadi dia gunakan 1 and 2. Means adalah primary, secondary. Primary, secondary. Secondary adalah primary. So 1 and 2 tu maksudnya merujuk pada primary dan juga secondary. Kalau 1 tu adalah primary dan 2 tu adalah secondary. So software lah. So formula ni wajib. Apa? Saya tahu. Kalau soalan tu bagi dalam bentuk kenyataan, kena declarekan, keluarkan maklumat-maklumat tu untuk soalan. Tu dah pada bagus. Dah lama dah kan? Ya? So ni contoh dia. A transformer is to be used to provide a 60 volt output. Apa maksud 60 volt output? Secondary itu. Kena pastilah. Dia soalan tu untuk ayat. Tetapi bagaimana kita nak manipulate dia? Kita nak classifykan dia dan kita keluarkan dalam bentuk formula tu supaya kita tak confuse. Itu step yang pertama kita kena buat. From 240 itu dari kan. So bila dari je maksudnya masukkan lah. Kalau kita listrik pun masukkan 240, masuk kepada PC watt dah kurang lagi ya. Okay. So kita kenal V1, VT, VS. Kata turn. Baik. Apa lagi? Calculate. Turn. Turn ni apa? N. Kita N. So kita dah ada ni. Lepas tu soalan tu dia nak calculate N. N apa? Kena pastikan pula. Ratio required by dan juga B. So ada dua soalan lah. Number of primary turn is the secondary. If the secondary is equal 500 turn. So ini adalah NP. Okay. If the secondary, mana pula NP? Secondary. Ayat dia baca betul. Dia kata if the secondary. So itu adalah F. Next. NP on seluruh. Saya ingat soalan. Buat ni semua. Saya tak datang, isi awal. Soalan yang pertama. Ini soalan yang kedua.
Salin.
Dah salin? Saya dah bagi nota. So kena pasti apa maklumat yang dia bagi, apa yang ada, dan apa dia suruh cari. Daripada bentuk ayat, dia dah transfer ke bentuk lita. So lagi mudah lah. Daripada bentuk ayat, dia dah transfer kepada bentuk lita. So dia suruh cari apa. Dia tu dah bagi Kemudian ni secondary. So kat sini. Kalau dia tak bagi lita ni, bagi soalan tu, boleh tak okey macam mana kita buat dalam kelas sebelum ni. Daripada soalan tu saya mesti dalam bentuk lita. Kita kena bagi transfer supaya kita lebih nampak, lebih faham dengan bukan tu. Ini pun satu keadaan tu. Kita dah gunakan nombor B tu berapa. So kita boleh dalam bentuk lita. So N1, N2 ni jangan confuse lah. Jadi untuk mengelakkan confuse, kita ukur kepada P dengan S. Sebab kita punya note banyak P dengan S. Primary dan juga secondary. So mana V1, P1 apa adalah primary. Okay. Ini transformer ratio. So disimbolkan dengan K. Jadi ini formula sama lah. Tapi check balik dia semua S. Secondary semua di atas. Sebab dia tak melibatkan arus. Kalau arus tadi yang IP je IS. So ini adalah formula bagi ratio. Mana yang kotak-kotak macam ni tu? Maksudnya awak kena ingat formula tu. Okay. Ini kan soalan. Ini dengan soalan lagi. Ini formula ratio ni soal dia. Apa itu S secondary EMF inductance, P primary, secondary dan juga VP primary terminal bukan voltage. Okay. So VP, VSC terminal. Terminal tu yang mana? Okay. Ini dah masuk terminal. Kalau pasaran lah. Okay, masukkan sebagai terminal. Alright. Soalan nombor 3. Selesaikan. Dia dah bagi NP, NS, I3. The number of within of the 3 transformer. Kalau 3 transformer ni apa? Lipid. Ini EMF, Electromagnetic Field. So dia formula dia simbol apa? Ini apa ni? Omega. Omega. Kita kena susul ke bila kita slay pun. Ini apa ni? Kita Tesla. Ini contoh soalan nombor 4 yang akan kita selesaikan besok Kita akan, ada beberapa soalan ni kita akan grupkan ya. Pun sama. Tiga phase ya. Tiga phase. F dah ada. So F dah ada. Kemudian N2, NS lah. 80. NS. Okay. So masuk nilai saja. Ikut kelab sensifo tu tadi. 5 sama, lebang. Semua juga kaitan